Now my next topic is related to the distribution of d electrons of the central metal cation in T2g and Dg orbital in high spin and low spin octahedral complexes. Now, in our previous in our previous video, we have to explain the what is high spin complex and what is low spin complex, and it depends on the spectrochemical series. Okay, now in spectrochemical series, that means I minus, Br minus, Cl minus, F minus, that means from left hand side to right hand side splitting power also increases. Now between I minus and F minus is stronger ligand than that of I minus. So that means, but in case of I minus to water, that means this is called a weak field ligand, that means it always from the high spin octahedral complex, and ammonia and Cn minus with strong field ligand, it always form the low spin complex. Okay, now next how electrons are distributed in T2g and Dg orbital. Now from the energy diagram, it has been observed that T2g orbital has less energy and Eg orbital has greater energy. Okay, so now in case of D, that means transition metal transition metal cation on always transition metal cation is starting from the scandium to copper. Zinc is not a transition metal atom. Okay, now in case of D1, that means cation means always the positive charge. Okay, so now in case if central metal cation has one electron, that means one electron present in D1, so that means if this first electron, according to above principle, always electron enter to the lowest energy orbital. So now in that case, between T2g and Eg orbital, T2g has less energy, so that means this is a lower energy orbital. So now in case of D1, only one electron present, that means one electron goes to the T2g orbital. So what is the electronic configuration? T2g1 Eg0. Now here P and Q, P is the number of electron present in T2g orbital and Q is the number of electron present in Eg orbital. So number of unpaired electron in that case of D1, only 1. Now in case of D2, same procedure, 1 and 2, so T2g2 Eg0. In case of 3, T2g3 Eg0, that means 3. Number D4, T2g3 Eg1, because it is single paired, then according to the single pair, and then one electron goes to the highest energy. Okay, next D5, T2g3 Eg2, 5 unpaired electron present. Okay, next D6, T2g4 Eg2, because after according to Hund's rule, if extra electron present, that means it goes to the next lower energy orbital and pairing takes place. So now in that case, T2g4 Eg2, next D7 T2g5 Eg2, next D8 T2g6 Eg2, and D9 means T2g6 Eg3, one unpaired electron, and D10 means T2g6 Eg4. Now this is the high spin complex. This is high spin complex means if ligand, that means I minus to water, if water is acts as a ligand, and if complex contain this type of ligand and this type of ligand, so the electron distribution, that means electronic configuration, that means is that type, that means T2g1 to Eg0 to T2g6 Eg4. Understand? And this is the electronic distribution of high spin octahedral complexes. Okay, understand? Okay.